All right, this is the 2022 question from the BC exam. This is a type 8 question. It has to do with parametric motion. And we're given a particle that's moving in the xy plane for time greater than 0. Particle moves with x velocity given by this equation and y velocity given by this equation. And then at time 4 we have a position. In part A, we're asked to find the slope of the line tangent to the path of the particle at time 4. So they are asking for what is the slope at time 4. In parametric, this would be calculated as dy dt over dx dt at time 4. Or you could write y prime of 4 over x prime of 4. If we evaluate y prime of 4, we stick 4 into this equation, we get ln of 18. And if we evaluate x prime of 4, we stick 4 into this equation, and we get the square root of 17. This is the exact answer. As a decimal, we get to 0.701. This question is worth 1 point. You get 1 point for the work which leads to the answer. It should be noted that if you wrote y prime of t over x prime of t equals this number, you would not get the point. You need to have y prime of 4 over x prime of 4. Moving on to part B. Part B asks us to find the acceleration vector at time 4. So the acceleration vector, as we know, would be x prime prime of t, comma, y prime prime of t. And we want to find the acceleration at time 4, so we're looking for x prime prime of 4 and y prime prime of 4. Now they provide us x prime and y prime, so we can take the derivative of x prime and y prime. We can take the derivative of x prime by hand, or we can use our calculator because it is a calculator active question. If we take the derivative of it by hand, we get 4 over root 17, and y prime, if we take the derivative of that by hand and evaluate it at 4, we'd get 4/9. Again, this is quite possible to do with the calculator, so if you had used your calculator to evaluate the derivatives, we'd get 0.970 and 0.444, or 4 repeating. So that's the second part of the question. The first part of the question was asking find the speed at time 4, which I skipped over accidentally. We know that speed is computed as the magnitude of the velocity vector. So x prime of 4 squared plus y prime of 4 squared. So that's our speed at time 4. And if we calculate that using our calculator, we would get the square root of 17 plus ln of 18 squared, or decimal 5.035. You get your first point for computing the speed. Numeric answers qualify as the point, so you don't have to reduce it all the way to here. However, since it is calculator active, you probably did get to that point. There are two more points. The first component of the acceleration vector is worth 1 point, and the second component of the acceleration vector is worth 1 point. So part B is a total of 3 points. Moving on to part C, we're asked to find the y-coordinate of the particle's position at time 6. This is a good classic, what I have is equal to what I started with plus what I accumulated. So the y position at time 6 is equal to my start position, and since we're given our start position at time 4, we'll do the accumulation from 4 to 6 of y prime of t dt. So what I have is equal to where I started plus what I accumulated from time 4 to 6. Y4 is provided to us in the question stem. They say at time 1 the particle starts at 1 comma 5. So, sorry, at time 4 the particle starts at position 5. Evaluating this integral expression, pretty difficult to do by hand, but it is a calculator active question. Evaluating that integral, we come up with that decimal using our calculator. So our position at time 6 is approximately 11.570. Using the rounding or truncating rule, 570 or 571 is an acceptable answer. You get your first point if you integrated y prime. That's worth 1 point. You get your second point if you used y of 4. And then you get your third point for having the correct final answer. Finally, the last question asks us to find the total distance traveled by the particle from time 4 to 6. Total distance traveled, we know, comes from integrating the speed expression This is the expression we'd use to calculate total distance traveled in parametric mode. If you wrote it using the information that they gave us, you could also write it as dx dt squared and dy dt squared. That's an acceptable way to do this. Again, computing this by hand would be tedious, if not impossible, but it is a calculator active question. So we can type it into a calculator. Being mindful to type it in correctly, we get the total distance traveled from t equals 4 to t equals 6 is 12.136. Full sentences are, of course, always better. But your first point comes from having an integrand, that is the speed function. And your last and final point comes from correctly computing the total distance traveled. Does my 2023 class, BC class, wish to say anything for the video?
Woo!
There we go. Thanks, Olivia.
Good luck on your studying.
Good luck on your studying. All right. Thanks, Jackson.